Hello all. Identities. In the last two lectures, we have seen how to do the dot product, cross product, how to find out the divergence, how to find out the curl. If they'll operated scalarly on the function phi, then you will get the divergence of given uh, for the surface phi. And if you operate del vectorly on the function phi, then we'll get your vector identities, that will be your curl. Okay. And now see, here we will see this properties to resolve this. Now del dot u bar plus or minus v bar is equal to del dot u bar plus or minus del dot v bar. Now del cross u bar plus or minus v bar is equal to del cross u bar plus or minus del cross v bar. Okay. Now here del dot phi of u bar is equal to phi of del dot u bar plus del phi dot u bar. Many times we will use these properties. Okay. So here is not dot, that is del cross v bar. Now, so del cross phi of u bar is equal to phi into del cross u bar plus del phi cross u bar. Now del of phi psi, where phi and psi both are scalars and u bar and v bar are vectors. If del operated on a vector, then del of phi of psi is equal to phi into del psi plus del phi psi. Okay, now del dot u bar cross v bar is equal to v bar dot del cross u bar minus u bar dot del cross v bar. Okay, so see the result. Let r bar is equal to xi bar plus yj bar plus zk bar, where r is equal to mod of r bar, and your vector a bar is equal to a1 I bar plus a2 j bar plus a3k bar. Then we will get del dot r bar is equal to 3. Now see, we will see how it is simple. Del dot r bar is equal to 3. If your del is I double, as I explained in the previous lecture, how we operate del. So I double by double x plus z double by double y plus k double by double z of r bar, that is xi bar plus yj bar plus zk bar. Okay, so you will get I into I dot I is 1, dot product with itself is 1, and double by double x of x, that is 1, plus z dot z is 1, double by double y of y is 1, plus k dot k is 1, and double by double z of this is 1. So 1 plus 1 plus 1, that is 3. So del dot r bar is equal to 3. You will get del dot r bar is equal to 3. Okay, so that is your scalar. Now del cross r bar. Now we will prove this del cross r bar. So कैसे आता है? Del cross r bar is equal to 0. If you operate del on that r bar, then you will get the cross product of this vector is equal to 0. Now in short, I will tell you here how to prove this or how we apply this result. So del cross r bar, it means cross product here I j k double by double x double by double y double by double z of r bar. R bar is here x component, y, z. So you will get here I into bracket double by double y of z, that is 0, minus double by double z of y, that is again 0, minus j into double by double x of z, that is 0, double by double z of x, that is again 0, plus k into double by double y of double by double x of y, again you will get 0, plus double by double y of x, that is again 0. So you will get ultimately here is 0. Okay, so I into 0 bar minus 0 bar, so again it means 0. So del cross r bar is equal to 0. Okay, now third one property, del dot a bar is equal to 0. Now for any vector a bar is equal to a1 I bar plus a2 j bar plus a3k bar, then you can take del dot a bar, it is always 0. So we can check it here, I double by double x plus z double by double y plus k double by double z dot a bar is a1 I bar plus a2 j bar plus a3k bar, right? So you will get a dot product of this vector. So double by double x of a, and again 0, plus dash dot z is 1, and double by double y of a2 is any scalar. So you will get again 0, k dot k is again a scalar, so double by double z of that, it is again a 0. Okay, so 0 plus 0, so you will get del dot a bar is equal to 0. Okay, Now we will see del cross A bar is equal to 0. Now we can find out del cross A bar. We will see del cross A bar here. Okay. So here is del cross A bar is equal to IJK. Del cross A bar, del is dabba by dabba x, dabba by dabba y, dabba by dabba z of A bar. A bar, it means here is A1, A2, A3, right? So you will get I into bracket dabba by dabba y of A3, that is constant hai, 0 aega. Then here dabba by dabba z of A1, again 0, minus z into dabba by dabba x of A3, 0, dabba by dabba z of A1, 0, plus k into dabba by dabba x of A2, 0, minus dabba by dabba y of A1, 0. So ultimately you will get del cross A bar is equal to 0. Okay. Now, the r bar dot r bar is equal to r square. It's a very simple. Many times we will use it here. Here your r bar is equal to xi bar plus yj bar plus zk bar, and r bar dot r bar, you can take the dot product, xi bar plus yj bar plus zk bar dot xi bar plus yj bar plus zk bar, right? So you will get here xi. So dot product with xi. So I bar dot I bar is equal to 1, and here is x square, y bar, y dot y. Z dot z is 1, so y into y square plus z square. So x square plus y square plus z square. So r bar dot r bar is equal to r square. So if you see here, r square is equal to the same. Okay, many times we will use r bar dot r bar is equal to r square, where r is equal to mod of r bar, right? Where r is equal to mod of r bar, and mod of r bar क्या होता है हमारा? Square root of, यहाँ पे आ जाएगा x square plus y square plus z square, right? This is your square root of mod of r bar, right? And mod of r bar is equal to r है, it means r is equal to ये हो गया x square plus y square plus z square. तो अभी r square हो जाएगा x square plus y square plus z square. Okay. Now let's. So del a bar dot del of r bar is equal to a bar, and del of a bar dot r bar is equal to a bar. First calculate del a bar dot r bar. So again you will get scalar, and that del of a bar, so you will get again vector quantity. So a bar cross r bar, you will get a vector quantity, and that dot product, so you will get again scalar quantity. But this is very important. Del of f of r is equal to f dash of r upon r into r bar. Okay, now we will see how to elaborate this identity. Now see first example. So del of f of r is equal to f dash of r upon r into r bar. Many times we will use this to solve the other identities. So this is the basic result of your vector identities here. Now we will see how to operate it. So f of r, it means is a function of r. Right? So f of r is a function of r. So we will write here del of f of r is equal to f dash of r upon r into r bar. So here you can write like r bar is equal to your r bar is given xi bar plus yj bar plus zk bar. Right? R bar is equal to xi bar plus yj bar plus zk bar, where then mod of r bar is equal to r is equal to square root of, you will get x square plus y square plus z square, right? Now we require del of f of r. So first we operate del on f of r. So del of f of r, I dabba by dabba x plus z dabba by dabba y plus k dabba by dabba z of f of r, here you will get I into dabba by dabba x of f of r plus j into dabba by dabba y of f of r plus k into dabba by dabba z of f of r. Right? So I into dabba by dabba x of f of r plus j into dabba by dabba y of f of r plus k into dabba by dabba z of f of r. Right? So f of r is a function of r. Now if you observe here, f of r is a function of r and r is a function of x, y, z. Right? F of r is a function of r and r is a function of x, y, z. So to find out the derivative of, now see we have to find out the derivative of f of r with respect to x. So see how we will elaborate this. Dabba by dabba x of f of r. Dabba by dabba x of f of r. We can write, now see here, f of r is a function of r. So first we will write dabba of f of r upon dabba r. So first we will take the derivative with respect to r and then derivative of r with respect to x. So dabba f of r upon dabba r into dabba r by dabba x. Okay, तो ये बन गया हमारा f dash of r. F of r upon r, it means f dash of r into dabba r by dabba x. So what is our r? R is the square root of x square plus y square plus z square. So differentiating this r with respect to x. So use that this as root u. So ये बन गया 1 upon 2 root u into derivative of u. Right? So into derivative of u with respect to x बन गया 2x. So is it nothing but so dabba f by dabba x of f of r is equal to f dash of r into ये हो गया 2 cancel out हो गया so x upon square root of x square plus y square plus z square, right? So which is equal to f dash of r upon x upon root of square root of x square plus y square plus z square is r. So we can write f dash of r into x upon r. Okay. So here f dash of r into x upon r, that will be your dabba by dabba x of f of r. Dabba by dabba x of f of r is equal to f dash of r into x upon r. Okay. So exactly similar way we can calculate dabba f of r upon dabba y. तो क्या मिलेगा हमें वो? Dabba by dabba y of f of r, which is equal to dabba f of r by dabba r into dabba r by dabba y. तो ये बन गया f dash of r into dabba r by dabba y. Exactly similar मिलेगा हमें y upon r, है ना? So dabba by dabba y, dabba by dabba z of f of r. So dabba f of r upon dabba r into dabba r by dabba z, which is equal to f dash of r into z by r. Right? So call this as equation number. If I said this is your equation number star, if I said this is your equation number star, then put 1, 2 and 3. Put 1, 2 and 3 in equation star. Okay? So you will get, in that star you will get dabba here del of f of r, you will get here del of f of r is equal to I into dabba f of r upon dabba x मिल गया हमें f dash of r into x upon r, f dash of r into x upon r of I plus f dash of r upon r into z or z bar plus f dash of r upon r into z k bar, right? ये यहाँ पे है y, y r bar z k bar. So you will get this. So ultimately, if I take f dash of r upon r common, so f dash of r upon r into bracket, we will get xi bar plus yz bar plus zk bar, right? So but xi bar plus yj bar plus zk bar is nothing but what? Is nothing but our r bar. So you will get del of f of r is equal to f dash of r upon r into r bar. Okay, I hope you are clear here. Del of f of r is equal to f dash of r upon r into xi bar plus yj bar plus zk bar, which is equal to f dash of r upon r into r bar. Many times we will use this result to prove the another results. Okay, so see the next property. Now, can anybody explain me how we will prove this? Del square of f of r is equal to f double dash of r plus 2 by r into f dash of r. ओके तो यहाँ पे हम लोग क्या करेंगे? डेल स्क्वायर ऑफ एफ ऑफ आर, तो हमें डेल स्क्वायर मतलब पता है डेल डॉट डेल, so you will write here del square of f of r is equal to del of f of r, राइट? तो del of f of r, तो अभी हमने जस्ट प्रूव किया del of f of r मतलब क्या है? f dash of r upon r into r bar, right? Your del of f of r, it means f dash of r upon r into r bar. Now if you see here, f dash of r upon r is a scalar quantity and r bar is a vector quantity, so can I write this as phi and this as u bar, right? So here we can write del of phi of u bar, so we can operate here del of phi of u bar. So क्या है हमारी प्रॉपर्टी? del of phi of u bar, del dot phi of u bar is equal to del phi dot u bar, del phi dot u bar plus phi into del dot u bar, right? So we will apply here, so you will get del phi. Phi मतलब क्या है हमारा? del of f dash of r upon r dot u bar. U bar मतलब है r bar plus phi into phi क्या है? f dash of r upon r into del dot u bar. U bar है हमारा r bar. Now I hope you are clear here. Del of f dash of r upon r into r bar plus f dash of r upon r into del dot r bar. Okay. So del phi of u bar, del phi of u bar is equal to del of f dash of r upon r. I am writing again here the same term. Del of f dash of r upon r into r bar plus f dash of r upon r into del dot r bar, है ना? Into del dot r bar here, right? So here del of f of r. So again f dash of r upon r is a function of r. So we can use the property 1 here. So क्या है हमारी property? Del of f of r की del of f of r is equal to f dash of r upon r into r, right? तो हमें इसके लिए अभी हमारा यहाँ पे f of r क्या बन f of r is equal to f dash of r upon r. ओके तो हमें इसका f dash निकालना है, तो f dash क्या हो जाएगा? u upon v के जैसे, तो f dash of r is equal to यहाँ पे मिलेगा हमें f double u upon v rule, so v du v into derivative of u minus u into derivative of v, ये बन गया du minus u dv into 1 derivative of r with respect to r upon v square, तो ये बन गया r square, right? तो ये हो गया हमारा del r into f double dash of r upon r, ठीक? तो यहाँ पे हो जाएगा f dash of r upon r, तो ये बन गया f dash of r, right? तो हम लोग क्या करेंगे यहाँ पे del of f of r, यहाँ पे जो भी है del of f dash of r upon r जो है ये क्या बन गया हमारा d by so f dash of r upon r है, तो ये सिर्फ f dash of r है, तो can I write this as, see again I am writing this term, okay? So this is for the calculation purpose only I have written. So from this again you will get del phi of u bar डेल फाई यू बार और डेल स्क्वायर ऑफ आर। तो ये मिल गया हमें r इंटू एफ डबल डैश ऑफ आर माइनस एफ डैश ऑफ आर अपॉन आर स्क्वायर, और ये अपॉन आर वाला तो ये यहाँ पे बन गया आर क्यूब इंटू आर। आई एम राइटिंग इंटू आर, ओके, इंटू आर बार, एफ डैश ऑफ आर अपॉन आर इंटू आर बार, ये हो गया सिर्फ इसका, और ये आर बार बचा हुआ, राइट, प्लस एफ डैश ऑफ आर अपॉन आर एंड डेल डॉट आर बार कितना आता है हमारा 3, as I already proved here, del dot r bar, see here, del dot r bar is equal to 3. तो यहाँ पे बन गया del dot r bar is equal to 3. So you will get del square of f of r is equal to r. अभी ये r जो है ये सेपरेट आउट करूंगी मैं तो क्या मिलेगा, f डबल डैश ऑफ r अपॉन ये r स्क्वायर है, सो r बार डॉट r बार क्या बन गया हमारा r into f double dash of r minus f dash of r upon r cube into ये r डॉट से डॉट प्रोडक्ट हम लोग एसोसिएटिविटी और डॉट प्रोडक्ट कर सकते हैं, तो यहाँ पे होगा r बार डॉट r बार, तो बन गया r स्क्वायर, राइट, प्लस f डैश 3 इंटू एफ डैश ऑफ r अपॉन r, तो ये r स्क्वायर और यहाँ का एक r कैंसिल आउट हो गया, तो ये बन गया r इंटू एफ डबल डैश ऑफ r अपॉन r माइनस एफ डैश ऑफ r, तो ये हो गया डेल स्क्वायर ऑफ एफ ऑफ r, डेल स्क्वायर ऑफ एफ ऑफ r इज इक्वल टू ये r कैंसिल आउट है, राइट, तो r एफ डैश ऑफ r अपॉन r बच गया, r एफ डैश एफ डबल डैश ऑफ r अपॉन r माइनस एफ डैश ऑफ r अपॉन r, राइट, plus 3f dash of r upon r, plus 3f dash of r upon r. Now if you see this cancel out, so f double dash of r minus, अब ये 3f dash of r upon r है, ये minus f dash of r upon r है, ये बन गया plus 2f dash of r upon r. That's we want to prove. Okay? Del square of f of r is equal to f double dash of r plus 2 into f dash of r upon r. I hope you are clear here. Del square of f of r is equal to f double dash of r plus 2 into f dash of r upon r. Okay? तो ये तो बन गया आपका del of f of r. No. Example number 3. Yeah, del of a bar dot r bar upon r raised to n. अभी ये देखो ये a bar dot r bar दोनों वेक्टर है, दो वेक्टर का डॉट प्रोडक्ट क्या हो जाएगा फिर से स्केलर, तो डॉट प्रोडक्ट ऑफ दिस टू वेक्टर्स इज स्केलर और ये भी स्केलर है, राइट, सो हमें एक तो किसी को तो यहाँ पे जो भी स्केलर है सो फाई साई करना पड़ेगा, तो फाई a बार डॉट r बार हो जाएगा साई 1 अपॉन r रेज़ टू n बन जाएगा, सो डेल फाई साई का हमारी प्रॉपर्टी यहाँ पे यूज करनी पड़ेगी टू प्रूव दैट दिस, so del phi psi is equal to, we can use del phi into psi plus psi in plus phi into del psi, okay, del phi psi plus phi into del psi, right, plus phi into del psi. तो यहाँ पे phi क्या अज्यूम करेंगे हम लोग, तो यहाँ पे phi क्या होगा 1 upon r raised बोलेंगे, यहाँ पे हमें phi is equal to 1 upon r raised to n is your phi and psi is equal to a bar dot r bar, ये भी वेक्टर डॉट प्रोडक्ट ऑफ दिस टू वेक्टर्स अगेन अ स्केलर, इसलिए हमें ये स्केलर ले रहे हैं, नहीं तो अगर ये वेक्टर आ जाता तो हम लोग u बार या v बार ट्रीट कर देते, ओके, सो यहाँ पे है del phi psi. So apply here property of del phi psi, that is a bar dot r bar upon r raised to n. You will get here. So your phi is 1 upon r raised to n. So ये मिल गया आपको del of 1 upon r raised to n into psi है आपका a bar dot r bar plus phi है आपका 1 upon r raised to n और del of a bar dot r bar. Okay, I think you are clear here how I applied the property. Okay, del phi psi plus phi del psi. Okay, del phi psi plus phi del psi. Now, लोग अभी ये del of f of r है, right? 1 upon r raised to n है, तो r this is again a function of r, तो यहाँ पे f of r क्या बन गया? f of r is equal to 1 upon r raised to n, which is equal to r raised to minus n. So f of r is equal to r raised to minus n. So you will get f of r is equal to r raised to minus n here. So f dash of r will be minus n into r raised to minus n minus 1, right? f dash of r बन गया f minus n into r raised to minus n. अभी del of a bar dot r bar upon r raised to n is equal to, I'm writing again as it is, del of 1 upon r raised to n. So del of 1 upon r raised to n into a bar dot r bar. Okay, so a bar dot r bar. So what will be our a bar dot r bar? Is a bar, right? A bar dot r bar, यहाँ पे हमें कुछ करना भी नहीं है, एज इट इज प्रूव करना है ना. ए बार डॉट आर बार है, वैसे ही रख दो. ए बार डॉट आर बार प्लस 1 upon r raised to n into del of a bar dot r bar. Del of a bar dot r bar, right? So here you can take del of 1 upon r raised to n. तो ये क्या हो गया? r raised to n. So f dash of del of f of r. So del of f of r, it means f dash of r. F dash of r. Okay, upon r into r bar. into r bar. ये हो गया del of f of r का elaboration. Del of f of r into means f dash of r upon r into r bar. अभी बच गया a bar dot r bar. Okay, यहाँ पे बच गया a bar dot r bar as it is हम लोग रखते हैं. Now if you see in your question, see n into r bar a bar dot r bar upon r raised to n plus 2. Now see यहाँ पे क्या हो जाएगा? a plus 1 upon r raised to n and del of a bar dot r bar, हमारी प्रॉपर्टी क्या है? del of a bar dot r bar की again a bar, we'll get again it is a bar, so a bar upon r raised to n. तो ये क्या बन गया हमारा? माइनस n इंटू ये हो गया a बार डॉट r बार. ओके, अब ये r रेज टू माइनस n माइनस 1 है, तो मैं क्या करती हूँ? डिनोमिनेटर में लाती हूँ, तो क्या हो जाएगा? r रेज टू n प्लस 1 हो जाएगा, और ये प्लस 1, तो r रेज टू n प्लस 2 बन गया, राइट? इंटू माइनस n हो गया r बार. यहाँ पे बच गया r बार प्लस a bar upon r raised to n. I hope you are clear. Now just write in a arrange the terms in a this way. So you will get a bar upon r raised to n minus n upon r raised to n plus 2 into a bar dot r bar into r bar. Okay, so you will get del of, just arrange the term, a bar dot r bar upon r raised to n, a bar dot r bar upon r raised to n is equal to, you will get minus a bar upon r raised to n, a bar upon r raised to n minus n into a bar dot r bar upon r raised to n plus 2 into r bar. Okay, that's it. We want to show that. Okay. So del of a bar dot r bar upon r raised to n is equal to a bar upon r raised to n minus n into a bar dot r bar upon r raised to n plus 2. R raised to n plus 2. This is r raised to n plus 2 into r bar. Okay, that's it. So similarly, we can prove these identities. So see the next one. So del square of del dot r bar upon r raised to 4 is equal to, show that. Now this is very important. Show that, or sometimes it is given that only find out del square of del dot r bar upon r raised to 4. Okay, so we have to find out this. Now it is one thing is very simple that क्या प्रूव करना है वो ऑलरेडी दिया हुआ है, मतलब आंसर क्या आने वाला है ये हमें पता है यहाँ पे, राइट? -12 upon r raised to 6, this is your answer. So we will apply. So del square, हमें तो सारी प्रॉपर्टीज पता है अभी. del square of del of r bar upon r raised to 4. Okay, del square of del of r bar upon r raised to 4. तो 1 upon r raised to 4 ये तो वेक्टर स्केलर बन गया और r bar ये तो वेक्टर है. सो phi into u bar की प्रॉपर्टी होगी del of phi of u bar. तो क्या होगा del phi into u bar, that is r bar, plus phi into del dot r bar. क्या कौन सी प्रॉपर्टी यूज की हमने? del phi u bar की, right? del phi dot u bar plus phi into del dot u bar. Okay, this property we have used here. So here r bar is your vector and r raised to 4 is a scalar. Okay. So del square of this, so you will get del square of del of f of r. अभी del of f of r कैसे करेंगे? So del of r raised to -4 बन गया into r bar plus 1 upon r raised to 4. तो del dot r bar क्या आ रहा है हमारा? 3. राइट, हमने पहले ही प्रूव करके रखा है del dot r bar is equal to 3. You can directly prove here or you can find out I double by double x plus z double by double y plus k double by double z of xi plus yz plus zk. So ultimately it will give you 1 plus 1 plus 1, that is 3. Okay. Now here we will find out del of f of r. So del of f of r मतलब क्या होगा? यहाँ पे आपका f of r है r raised to -4. तो f dash of r क्या बन गया? -4 r raised to -5 equal to -4 upon r raised to 5. Right? F of r is equal to r raised to -4 and f dash of r is equal to -4 into r raised to -5, that is -4 upon r raised to 5. Okay, तो आपको यहाँ पे मिल गया f dash of r is equal to this. लोग डायरेक्टली यहाँ पे प्रूव करते हैं. सी del square of del of r bar upon r raised to 4, del of r bar upon r raised to 4 is equal to, ये बन गया हमारा del square of अभी del of r raised to -4. तो del of r raised to -4 क्या हो गया? f dash of r upon r. तो f dash of r क्या है हमारा? -4 upon r raised to 5, -4 upon r raised to 5 into r, right? 1 upon r again. del of f of r क्या है? f dash of r upon r into r bar, right? ये है हमारा f dash of r upon r, this into r bar. ओके, और ये पहले वाला r bar जो ऑलरेडी है यहाँ पे मौजूद. तो ये हो गया r bar dot r bar. I hope you are clear. Okay, f dash of r upon r into r bar into r bar. Okay, now ये बन गया हमारा plus 3 upon r raised to 4 plus 3 upon r raised to 4. Can calculate here del square of, यहाँ पे हो गया ये r square, तो ये r square cancel out हो जाएगा, r bar dot r bar, so -4 upon r raised to 6 हो गया ये, और into r square plus by r raised to 4, right? तो ये r square और ये r square cancel out हो गया, तो del square of बन गया -4 by r raised to 4 plus 3 by r raised to 4. ये बन गया आपका del square of -1 by r raised to 4. See, this is a very simple. Now directly we can apply the property of del square of f of r. जो हमने अभी प्रूव की है. del square of f of r क्या है? Del square of f of r is equal to f double dash of r plus 2 by r into r bar, right? So del square of f of r हमारा बन गया यहाँ पे by r into f dash of r. 2 by r f double dash of r into 2 by r into f dash of r. ठीक है, तो हमें यहाँ पे f of r है आपका -1 अपॉन r रेज टू 4. f of r है हमारा f of r is equal to -1 upon r raised to 4, which is equal to minus r raised to -4. Okay, so f dash of r क्या बन गया हमारा, f dash of r क्या है, माइनस ऑफ माइनस, so ये बन गया +4 r raised to -5, which is equal to 4 upon r raised to 5, right? f dash of r बन गया 4 upon r raised to 5. तो f double dash of r क्या बन गया हमारा, -20 into r raised to -6 equal to -20 upon r raised to 6. f of r, f dash of r, f double dash of r. ओके, अभी हम लोग प्रूव करेंगे डेल स्क्वायर ऑफ, अब हमारा बन गया डेल स्क्वायर ऑफ f of r is equal to डेल स्क्वायर ऑफ डेल ऑफ r bar upon r raised to 4 is equal to डेल स्क्वायर ऑफ क्या है हमारा, -1 अपॉन r raised to 4. कैलकुलेशन है यहाँ पे फॉर द कैलकुलेशन पर्पस ओनली. तो डेल स्क्वायर ऑफ r अपॉन डेल स्क्वायर ऑफ -1 अपॉन r raised to 4, डेल स्क्वायर ऑफ -1 अपॉन r raised to 4. तो अभी ये डेल स्क्वायर ऑफ -1 अपॉन r raised to 4 हो गया. तो यहाँ पे f डबल डैश ऑफ r, जस्ट यूज f डबल डैश ऑफ r क्या है हमारा, -20 अपॉन r raised to 6, -20 upon r raised to 6 plus 2 upon r into f dash of r. f dash of r क्या है आपका, 4 by r raised to 5. तो ये क्या बन गया हमारा, -20 upon r raised to 6 plus 8 upon r raised to 6, r raised to 5 into r. तो -20 plus 8 तो बन गया -12. तो -12 upon r raised to 6, that's we want to. I hope you are clear how to prove the identities. These identities are very important for the engineering mathematics 3, in that chapter vector differentiation. Okay, so in that we will see the vector identities, how to prove the vector identities here. So del square of del of r bar upon r raised to 4 is equal to -12 upon r raised to 6. Okay. Now, example 5 here, del raised to 4 of r square into log r. Okay, अभी del raised to 4 है तो हमें क्या करना है, now it's a very simple. Okay, अभी आपको समझ में आ गया होगा कि del की प्रॉपर्टी हमें कैसे यूज करनी है. del raised to 4 of r square into log r, right? तो यहाँ पे होगा del raised to 4, it means del square of r square log r. Okay, तो यहाँ पे हम लोग क्या करेंगे, ये डेल स्क्वायर ऑफ आर स्क्वायर लॉग आर है, ये हो गया आपका एफ ऑफ आर फॉर दिस डेल स्क्वायर. ओके, तो यहाँ पे मैं लिखती हूँ एफ ऑफ आर इज इक्वल टू आर स्क्वायर लॉग आर. तो उसके लिए डेल स्क्वायर है तो एफ डबल डैश ऑफ आर लगेगा हमें. तो एफ डैश ऑफ आर क्या हो जाएगा हमारा, यूवी रूल अप्लाई करना पड़ेगा बिकॉज बोथ आर फंक्शंस ऑफ आर. तो फर्स्ट इनटू डेरिवेटिव ऑफ सेकंड प्लस सेकंड इनटू डेरिवेटिव ऑफ फर्स्ट. डेरिवेटिव ऑफ फर्स्ट आएगा 2r into log r. Okay, तो ये बन गया r plus 2r log r. ये बन गया आपका f dash of r. अभी f double dash of r, f double dash of r, r का यहाँ पे बन गया 1 और 2 into bracket r into log r, first into derivative of second plus second into derivative of first. Okay, ये बन गया, ये कट हो गया तो आपको मिल गया 1 plus 2 into bracket 1 plus log r, 1 plus log r. अभी जो जो चाहिए वो तो मटेरियल हमने यहाँ पे इकट्ठा कर लिया. सो एफ डबल डैश ऑफ r इज इक्वल टू 1 plus 2 into r plus 2 into 1 plus log r. ये बन गया आपका एफ डबल डैश ऑफ r. अब हम ये बैक टू द यहाँ पे आएंगे हम लोग, तो डेल स्क्वायर ऑफ यहाँ पे क्या हो जाएगा, डेल स्क्वायर डेल रेज टू 4 ऑफ r स्क्वायर log r. तो मैं कैसे प्रूव करूंगी, डेल स्क्वायर ऑफ, फिर डेल स्क्वायर ऑफ यहाँ पे हो गया एफ ऑफ आर, तो डेल स्क्वायर ऑफ एफ ऑफ आर क्या है हमारा एफ डबल डैश ऑफ आर, तो एफ डबल डैश ऑफ आर क्या है 1 प्लस, यहाँ पे बन गया 1 प्लस टू लॉग आर, तो यहाँ पे हो गया 3 प्लस लॉग आर, राइट, 3 प्लस टू लॉग आर, 1 प्लस टू लॉग आर, तो ये बन गया 1 प्लस 1 दैट इज 3 लॉग आर, ओके, तो ये हमारा बन गया log r, so 1 plus 2 f double dash of 2 3 plus 2 log r, so this is your f double dash, this is your f of r for this del square of r, right, del square of r के लिए f double dash of r plus 2 by r, okay, plus 2 by r into f dash of r, तो f dash of r क्या है हमारा r plus 2r log r, right, so 10 raised to 4 into r square log r is equal to del square of 3 plus 2 log r plus 2 by r into r, तो बन गया 2, तो r कैंसिल आउट हो जाएगा, यहाँ पे 2 प्लस, राइट, ये r कैंसिल आउट हो गया, सो 2 प्लस, यहाँ पे बन गया ये r कैंसिल आउट हो गया 4 log r, 2 plus 4 log r, okay, so ultimately ये क्या मिल गया 2 3 plus 2, so this will be your 5 plus 6 log r, ये बन गया अभी आपका f of r, तो f of r क्या हो गया f डबल डैश ऑफ r, तो f डैश ऑफ r पहले निकालेंगे, f डैश ऑफ r हो गया ये 0, ये बन गया 6 अपॉन r, f डबल डैश ऑफ r क्या बन गया हमें माइनस 6 अपॉन r स्क्वायर, देखो अभी यहाँ पे हो गया डेल रेज टू 4 इंटू आर स्क्वायर, डेल रेज टू 4 इंटू आर स्क्वायर लॉग आर इज इक्वल टू एफ डबल डैश ऑफ आर, तो एफ डबल डैश ऑफ आर बन गया माइनस 6 अपॉन आर स्क्वायर प्लस 2 अपॉन आर इंटू एफ डैश ऑफ आर, तो एफ डैश ऑफ आर क्या है हमारा अपॉन आर, तो माइनस 6 अपॉन आर स्क्वायर प्लस 12 अपॉन आर स्क्वायर, ये बन गया माइनस 6 प्लस 12 6 अपॉन आर स्क्वायर, दैट्स इट, okay, the simple way how to elaborate the vector identity, okay, or how to apply the vector identity. I hope you are clear here how to apply the vector identities. Now the next point is line integral, okay, how to calculate the line integral. And the next point is how to calculate the line integral. Okay, now see, the line integral करना है, see, suppose this is your line, so integrating this, so instead of that what we will do, we will take a integration of these small parts and adding this integral we will get the total line integral, okay. लाइन इंटीग्रल क्या है डेफिनेशन हमारी, एफ बार इज इक्वल टू, हमने देखा है कल, एफ बार इज इक्वल टू f1 ऑफ xyz i bar प्लस f2 ऑफ xyz j bar प्लस f3 ऑफ xyz k bar and dr bar is equal to, now we know that r bar is equal to xi bar plus yj bar plus zk bar, right, so dr bar क्या आएगा dxi bar plus dyj bar plus dzk bar, then integrating f bar dot dr bar, taking dot product with these two, okay, taking dot product of these two, so f bar dot dr bar, so f1 of xyz dot xi bar, so I bar dot I bar 1, So you will get integral of f1 of xyz dx plus f2 of xyz dy plus f3 of xyz dz. Okay, so your integral of f bar dot dr bar is equal to this. Now work done. So work done is given by, so work done by a force f bar in moving or displacing a particle along a curve C from point say P1 to P2. Okay. So here you will get the, okay. So f bar dot dr bar. So work done, it's a point. Suppose this is your curve C, and here is a point P1 to point P. We can calculate, this is your curve C. So work done is nothing but the integral from the point P1 to P f bar dot dr bar. Okay, this is our work done. Okay, we can calculate the work done by using the formula integral over C from the point P1 to P2 f bar dot dr bar. Okay, no. The next example, that is calculate the work done. Okay, so along the find the work done or integral over C f bar dot dr bar is given by, yeah, integral over C f bar dot dr bar is given by or evaluate. So it is not given calculate the work done or whatever. If it is given directly like this, so automatically we have to assume that this is a work done. This is definition of work done, right? This is the definition of work done. So integral over C f bar dot dr bar for f bar is equal to 3x square I bar plus 2xz minus yz bar plus zk bar along the straight line joining 0 0 0 to 1 2 3. ओके, वर्क डन के लिए क्या करना होगा हमें, जो भी आपका एफ बार और डी आर बार है, try to convert it into one variable because we have to integrate with respect to either. So we will convert it into the one variable and the equation of the straight line given. Okay, so equation of the straight line is given. It means path of integration is given. That is your straight line. A straight line joining these 2 points 0 0 0 to 1 2 3. So this is a straight line joining these 2 points. Now, here path of integration is given. It means points are given. We can find out the path of integration or equation of a straight line by using this x1, y1, z1, x2, y2, z2. Okay. So first of all, we will write down this. Let I is equal to our integral. Let I is equal to integral over c f bar dot dr bar. Okay. So which is equal to integral over c. F bar क्या है हमारा 3x square I bar plus 2xz minus yz bar plus zk bar dot dr bar. So dr bar it means I dx plus z dy plus k dz, right? The dot, take the dot product, so you will get integral over c f bar dot dr bar is equal to integral over c f bar dot dr bar is equal to, you will get integral over c here x square dx plus 2xz minus y dy plus z dz. Okay, 3x square dx plus 2xz minus y dy plus z dz. ये हो गया integral over c f bar dot dr bar. Okay, now the points are given, so we will find out the path of integration is given, that is straight line, and joining, so joining the points are given, so we will find out the equation of a line. Okay, so equation of a line joining the points, equation of a point, equation of a line, sorry, equation of a line joining the points, joining the points equation of the line joining the points x0, y0, z0, that is your 0, 0, 0, 2, 1, 2, 3. Okay, 0, 0, 0, 2, 1, 2, 3. So here you will get x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1 is equal to t. Okay, so here you will get x minus x1. So x minus x1, this is your x1 y1 z1 and x2 y2 z2. So x minus x1, it means x minus 0, x2 minus x1 1. Here y minus 0 upon 2 minus 0 is equal to z upon 3 z minus 0 upon 3 minus 0 is equal to t. So you will get x is equal to t, y is equal to 2t and z is equal to 3t. Okay, so x is equal to t, y is equal to 2t and z is equal to 3t. So you will get dx is equal to dt, dy is equal to 2 dt and dz is equal to 3d. Just substitute in your this equation and elaborate. Now see, if you observe here, now x is varying from, the limits are varying from 0 to 1. Okay, x is varying from 0 to 1, y is varying from 0 to 2 and z is varying from 0 to 3. So ultimately you will get t is varying from 0 to 1. You see, if I put x is equal to 0, you will get t is equal to 0. Okay, if I put x is equal to 1, you will get t is equal to 1. If I put y is equal to 0, t is equal to 0. If I put y is equal to 2, you will get t is equal to 1. If I put z is equal to 3, then z is equal to 0, then t is equal to 0, and if z is equal to 3, then t is equal to 1. So ultimately your standard limit for t is varying from 0 to 1. Okay, so everything we will put in this equation. So integral over c f bar dot dr bar is equal to integral over c f bar dot dr bar is equal to, you will get integral over c f bar dot dr bar is equal to 3x square dx 0 to 1 3 into, but x is equal to what? T, 3t, and dx is equal to dt. And so 3t dt plus 2xz minus y. So 2 into xz minus y, 2xz minus y, but 2 into x is equal to t and z is equal to dt, minus y is 2t. So you will get 6t square minus 2t and dy is 2 dt. So you will get 12t square minus 4t dt. So here is 12t square minus 4t dt, right? So ultimately plus यहाँ पे क्या करना है अभी, into z dz. So z क्या है 3t. So you will get only 3t into 3 dt, right? So ultimately your total integral is converted in terms of t. So I'm taking only 3t plus 12t square minus 4t plus 9. You get integral 0 to 1. 3t minus 4t minus t plus 9t, that is 8t. We will get it is 8t dt. So 3t square, no, I think is x square. So here is 3t square. So 3t square plus 20 square, you will get 15t square plus 5t dt. So integrating this 0 to 1. So integration of 15t square, you will get 15 into t cube by 3, t square by 2, 15t given to 5. So which is equal to 5t cube 5t cube plus 5 by 2 t square from 0 to 1. Okay. So which is equal to, this is 5 plus 5 by 2 minus 0. Right? So this is 10, 15 by 2. Okay. So the final answer of your work done, that is f bar dot dr bar along the given path, is f bar dot dr bar is equal to 15 by 2. Okay. I hope you are clear. Now you look at this calculation. I will be back with 1 minute. Now f bar dot dr bar is equal to 15 by 2. Cover up. See the next example, that is f bar is equal to 2x plus y square into I bar plus 3y minus 4x z bar. Then evaluate f bar dot dr bar around the parabolic arc. Now here path of integration is different. Parabola is given, y square is equal to x. So joining 0, 0 to 1. Have to find out the path of this parabola is equal to x. Find out the further y square is our parabola. That parabola y square is equal to x. Even here is 0, 0. Or somewhere you will get here is 1. Right? This is the point, here is 1, 1. So here this is your curve C. Now we will find out the integral over curve C. Now path joining the points from 0, 0 to 1, 1. Okay, path joining the point from 0, 0 to 1, 1. Okay. Now see what we will do. Here f bar is given. Your given curve, your given curve is y square is equal to x. Okay. So which implies dy is equal to root x. Right? So we can write dy is equal to 1 upon 2 root x dx. We will convert in terms of x only. Whenever your f bar dot dr bar is there, so consider first I is equal to f bar dot dr bar. For integral I equal to integral of f bar dot dr bar, which is equal to, so shall I write directly f bar dot dr bar here? So f bar dot dr bar is your integral of 2x plus y square dx, right? 2x plus y square dx and plus 3y minus 4x dy plus 3y minus 4x dy. Okay. 2x plus y square dx plus 3y minus 4x dy. So this is your I. Now we'll find out C. So put y is equal to root x and dy is equal to 1 upon 2 root x dx. So how your x is varying from? X is varying from here. If I put x is equal to 0, then y is equal to 0. If I put x is equal to 1, then y is equal to 1. So x is varying from, see here, x is also varying from 0 to 1. So 0 to 1, x varying from 0 to 1, varying from 0 to 1. So ultimately your integral becomes I is equal to integral of from 0 to 1 a bar dot dr bar. So here 2x plus y square is equal to x and dx as it is plus 5 y is equal to root x minus 4x into dy is 1 upon 2 root x dx. Simplify this. First, integral 0 to 1. So 2x plus x is 3x plus, here is 3 root x minus 4x. Right? Here is minus 4x into 1 upon 2 root x dx. Just a bit. There is d plus. Here you will get 3 root x upon 2 root x. 3 by 2 only. Root x cancel out. Minus 4 by 2 root x. So you will get root x here because 1 root x will cancel out. 2 root x. 2 into root x to dx. Ultimately you will get 3 by 2. So integration of this is 3 into x square by 2 plus 3 by 2x minus 2 into x raised to 1 by 2 plus 1. So x raised to 3 by 2. So 2 into x raised to 3 by 2 upon 3 by 2 from 0 to 1. So this will gives you, just put the integral limits. So here 3 into 1. So this will be 3 by 2 plus 3 by 2 minus 2 into, so minus that is nothing but 4 by 3. Okay. So minus 4 by 3. So ultimately you will get 3 by 2 plus 3 by 2, it means 6 by 2, 3 minus 4 by 3. So 9 minus 4 by 3, which is your final answer will be 5 by 3. I hope you are clear here. Okay. So I hope you are clear here how to find out the integral, line integral, or how to find out the work done. Line integral is nothing but the work done. Okay. Now see here this example. Find the work done by the force F bar is given x square minus yz I bar plus y square minus zx z bar plus z square minus xyk bar in taking the particle from 1 to 1 to 2 minus 5 7. In taking the particle from 1 to 1 to 2 minus 5 7. Okay. तो यहाँ पे ये कैसे करना है 1 to 1 to 2 minus 5 7. We will see here. So इसमें path of integration is not given, but we know that if path of integration is not given, or it means the surface is not given, how to find out it? First we will check that so del cross f bar is 0 or not. So in the last lecture we have seen how to find out the uh, del cross f bar. Okay, how to find out the del cross f bar here? Find the del cross f bar. If del cross f bar is equal to 0, then there exists a scalar potential phi. So we can find out del phi by using the exact rule. So we will check first of all f bar is irrotational or not. Okay. So Rudolph swing. Here path of integration is not mentioned. Okay. Here path of integration, right enough. Okay. Here path of integration is not given. Okay. Their path of integration is not given. So what we will do? So W is equal to your work done is equal to closed integral over C f bar dot dr bar. Okay. So observe that for the vector field del cross f bar, we will observe if the vector field del cross f bar is equal to 0, then is irrotational, then there exists a scalar potential phi if del cross F bar is equal to 0, then there exists a scalar potential phi, and there exists a scalar potential phi such that F bar is equal to del phi. Okay. So we will calculate F bar dot dr bar is equal to del phi dot dr bar, which implies F bar dot dr bar is equal to phi. Right? So you will get phi, and after that phi we can find out taking into the integral from 1 to 1 to minus phi 7. So we will first of all find out, check whether the given vector field F bar is irrotational or not. Okay. So for that we consider del cross F bar. So we can find out del cross F bar. Yesterday's lecture we have seen how to calculate the curl of F bar, that is nothing but the del cross F bar. So dabba by dabba x, dabba by dabba y, dabba by dabba z. So F bar is, F1 bar is x square minus yz, square minus yz. Okay, y square minus zx, y square minus zx, and z square minus xy. I say k. So you will get here I bar into bracket dabba by dabba y of this. We will get minus x minus dabba by dabba z of this. So minus of minus, so plus x minus z into bracket dabba by dabba x of this. So minus y minus dabba by dabba z of this. So of minus plus y plus k into bracket dabba by dabba x of this minus z minus dabba by dabba y of this minus of minus plus z. So ultimately you will get del cross F bar is equal to 0, which implies F bar is irrotational. If F bar is irrotational, then there exists a scalar potential phi. And find out the scalar potential phi is equal to, then there exists scalar potential phi, such that here you will get integral of phi is equal to, you will get integral of f1 dx. Okay. Integral of f1 dx, so x square minus yz dx, keeping yz constant. Okay. Plus terms of f2 which are free from x. Only एक ही term है यहाँ पे y square है which are free from x, so yes, so y square dy. Terms of f2 which are free from x, that is y square dy, keeping z constant, plus terms of f3 which are free from x and y. Terms of f3 which are free from x and y, so z square minus xy. Free from x and y, so only z square dz. Okay, plus c. I hope you are clear here up to this step. Now the points are given here, keeping y and z constant. So you will get x cubed by 3 minus xyz. Okay, minus xyz plus here integral of y square, that is y cubed by 3, plus here you will get z cubed by 3. Y cubed by 3, so x cubed by 3 minus xyz. So this is up the point. From the points are given 1 to 1 to 2 minus 5 7, 1 to 1, 1 to 1 to 2 minus 5 7, 1 to 1 to 2 minus 5 7 is given 1 to 2 minus 5 7. Okay. Now next is, so phi will be, your phi will be here Now put the values. X is equal to 2, 2 cube is 8, 8 by 3. In here 8 by 3 minus x is equal to 2, y minus 5 plus 10 into 7, 70 you will get here. So plus 70, 8 by 3 minus 70. 8 by 3 minus 70 plus y cube minus 125 by 3 minus 125 by 3 plus z cube. Z cube is 7 cube. We will get 7 cube is 343. 343 by 3. So 7 cube is 343 by 3 plus c. Okay. So we will get this 343 by 3 plus c minus, here you will get minus, so minus of, put x is equal to 1, y is equal to 2 and z is equal to 1, so that you will get here x is equal to 1, 1 by 3 minus here 2 plus 1 by 3, sorry 2 cube is 8 by 3 plus 8 by 3 plus 1 by 3 and plus, after adding this you get phi is equal to 432 by 3, ultimately we get 432 by 3, 432 by 3 equal to 140. Now work done is 144. Okay. Now I hope you are clear here. I covered all the three types: when the path of integration is straight line, when the path of integration is a parabola, and when the path of integration is not given, then how to calculate the work done. I hope you are clear here how to calculate the work done by using all the three methods. So the very important theorem. So whatever we have done up to this 1 hour, so this is very useful to find out the line integral by using Green's theorem, which is very well known theorem to find out the line integral. So here u of xy and v of xy are continuous functions of x and are continuous functions and x and y, and u possesses a continuous partial derivatives with respect to x and y, that is dabba u by dabba x, dabba u by dabba y, dabba v by dabba x, dabba v by dabba y. It means u and v both possesses a partial derivatives with respect to x and y. Okay, now are also continuous in a region R in xy plane. These are also continuous in a region R in a xy plane. Okay, so then the integral, closed integral over C u dx plus v dy is equal to the double integral over the region R into dabba v by dabba x minus dabba u by dabba y into dx dy, where C is transverse in an anti-clockwise direction. Okay, and R is bounded by the region, bounded by the given closed curve C. ओके, यहाँ पे हम लोग मीनिंग देखते हैं कि ग्रीन्स थ्योरम मतलब क्या है. जो भी कर्व आपको दिया हुआ है, सपोज दिस इज योर क्लोज्ड कर्व सी. Now suppose this is your any closed curve C, you can take any curve. So this is your closed curve C, it must be a closed. Now what we have to find out, this line integral, यहाँ पे आपको जो line दिख रही है ना, I will show you the line here. See this line, or this is the region. The line integral is same as the region bounded by, see the line is transverse in an anti-clockwise direction. This is your anti-clockwise direction. This is your curve C. curve C, and this curve C bounded by this region. This is your region R. Okay, and this is your curve C. मतलब ये जो लाइन इंटीग्रल का आंसर है, मतलब इंटीग्रेशन है, जो भी हम लोग ये लाइन इंटीग्रेट करेंगे, ये लाइन इंटीग्रल और दिस रीजन सेम. Okay, line integral and the region bounded by this line same. Okay, so this we have to prove that by using Green's theorem. The line integral is same as the region bounded by that curve, closed curve C. Okay, so we will verify it in the first example. Verify the Green's theorem in the plane closed integral over C xy plus y square dx plus x square dy, where C is the closed curve of the given region bounded by y is equal to x and y is equal to x square. हमें यहाँ पे ग्रीन्स थ्योरम वेरीफाई करना है कि ये दोनों फंक्शन ने जो भी कर्व बाउंड किया हुआ है उसका रीजन का इंटीग्रल और लाइन का इंटीग्रल सेम होता है. okay? मतलब एरिया जो भी है वो सेम है बाउंडेड बाय दिस टू कर्व्स. लोग यहाँ पे देखेंगे क्या क्या रीजन है हमारे. y is equal to the line y. Okay, y is equal to x is the line passing through the origin, right? ये आपकी लाइन ये है कोऑर्डिनेट एक्सिस में अलग दिखाते हैं लाइन. द लाइन y is equal to x is the line. Y is equal to x is the line which is passing from the origin, and we will see the closed parabola in the find out first parabola and then we'll draw the more simpler form. Draw the line y is equal to x. Okay? तो यहाँ पे जो भी लाइन है हमारी the line, yeah, the curve which is passes through this point the region bounded by these two curves is this region. This is the region which is bounded by both the closed curves. See, y is equal to x and y is equal to x square is the parabola. Okay, so what's our Green's theorem states that Green's theorem states that here integral over C, closed integral over C, right? Closed integral over C f bar dot dr bar is equal to double integral over r dabba v by dabba x minus dabba u by dabba y into dx dt. तो फर्स्ट हम लोग क्या करेंगे, लाइन इंटीग्रल इलेबोरेट करेंगे. तो लाइन इंटीग्रल है मतलब हमें यहाँ पे ये पॉइंट देना है, तो पॉइंट ऑफ कांटेक्ट क्या क्या आएंगे हमारे, y इज इक्वल टू x है तो y इज इक्वल टू 0 हो गया, तो ये भी हो गया x इज इक्वल टू 0. पॉइंट एक मिल गया x 0 0 यहाँ पे, राइट. 0 0 इज द पॉइंट, दिस इज योर o, ओरिजिन o. और यहाँ पे जो पॉइंट है ये पॉइंट ऑफ कांटेक्ट है हमारा, ये है पॉइंट ऑफ कांटेक्ट. और एक ये है पॉइंट ऑफ कांटेक्ट, ये है पॉइंट O और ये है पॉइंट, हम लोग बोलेंगे इसको पॉइंट, सपोज दिस इज B. और B क्या होगा, y इज इक्वल टू 1 तो x इज इक्वल टू 1, x इज इक्वल टू 1, y इज इक्वल टू 1. तो ये दोनों पॉइंट ऑफ कांटेक्ट मिल गए हमें. सो योर इंटीग्रल, योर बोथ द वेरिएबल्स आर वेरिंग फ्रॉम 0 to 1. तो हम लोग क्या करना है, अभी लाइन इंटीग्रल फाइंड आउट करना है. तो इसके लिए अभी हमने देखा कि यहाँ पे ग्रीन्स थ्योरम बोलते हैं ट्रैवर्स द क्लोज्ड कर्व सी. तो हमारा क्लोज्ड कर्व सी कौन सा है, ये जो हाफ वाली ग्रीन वाली लाइन है और ये जो कर्व ब्लू वाली लाइन है, दैट विल बी योर क्लोज्ड कर्व सी. सो हम लोग क्या करेंगे, यहाँ पे ओ ए बी इज द कर्व एंड यहाँ पे होगा आपका ओ ए बी एक कर्व होगा और ये होगा हमारा पी ओ एक आर्क. तो टोटल यूर क्लोज्ड इंटीग्रल ओवर सी और क्लोज्ड इंटीग्रल ओवर एफ बार डॉट डी आर बार जो भी है वो होगा क्लोज्ड इंटीग्रल ओवर, तो लाइन इंटीग्रल है आपका ओवर सी ओ ओ ए बी पे एफ बार डॉट डी आर बार प्लस अलॉन्ग पी ओ कर्व होगा एफ बार डॉट डी आर बार. अलोंग ओ ए बी होगा और अलोंग बी ओ होगा. हम लोग अलोंग ओ ए बी एंड अलोंग बी ओ निकालेंगे यहाँ पे कर्व. तो ये क्या हो जाएगा, अलोंग ओ ए बी एंड बी ओ निकालेंगे तो क्या मिलेगा हमें, तो अलोंग ओ ए बी, here along the line O A B, along line O A B क्या है हमारा कर्व, along line O A B here y is equal to x square है जो कि स्टैंडर्ड लाइन है. OAB y is equal to x square लाइन है. Along line OAB y is equal to x square. So you will get dy is equal to 2x dx. Right? So x varies from where to where? X is varying from 0 to 1 here. You can see here x is varying from 0 to 1. और क्या है? Okay, so we'll elaborate the line integral over OAB f bar dot dr bar. So you will get integral along OAB है 0 to 1. तो हमारा f bar क्या है, xy plus y square into dx, xy plus y square into dx plus x square dy plus x square dy which is equal to integral from 0 to 1 x into y, y is equal to क्या है x square, right. तो ये मिल गया x cube plus y is equal to x square है तो x raised to 4 dx plus x square into dy, dy है 2x dx. So you will get integral over 0 to 1 x cube plus x raised to 4 plus 2x cube into dx. So ultimately you will get integral along OAB f bar dot dr bar is equal to integral from 0 to 1 x cube plus 2x cube बन गया 3x cube 3x cube plus x raised to 4 dx. Okay, 3x cube plus x raised to 4 dx. So you will get 3x cube plus x raised to 4 dx. तो ये बन गया integration of this 3x raised to 4 by 4 plus x raised to 5 plus x raised to 5 by 5 from 0 to 1. Okay, so you will get here 1 by 4, 3 by 4 plus 1 by 5. 3 by 4 plus 1 by 5 which is equal to 15 plus 4, 19 by 20. So ये बन गया 19 by 20 19 by 20 और ये हो गया x cube plus x raised to 4. Okay. Here total 19 by 20. So along BO है हमारा y is equal to x है ना. Along BO line है हमारी y is equal to x. See here BO. So your line y is equal to x and x is varying from 1 to 0. X is varying from 1 to 0. तो हमारा इंटीग्रल अलोंग BO बन गया f bar dot dr bar is equal to from 1 to 0. BO क्या है? from f bar dot dr bar क्या हो जाएगा यहाँ पे dy is equal to dx है, राइट. y is equal to x है तो dy is equal to dx है. तो पूरा x में कन्वर्ट हो जाएगा आपका dy. so 3 यहाँ पे है y is equal to x. so x square plus x square dx. so x raised to 4 हो जाएगा और ये हो जाएगा x raised to 4. so x into dy is equal to dx. तो आपका बन जाएगा ये x raised to 4 ना. y is equal to x है तो ये x square plus x square 2x square plus x square 3x square. along BO बन गया हमारा 3x square dx. टोटल मिल गया हमें 3x square dx from 1 to 0. तो ये बन गया 3x cube by 3 from 1 to 0. तो बन गया 0 minus 1. 3 by 3 cancel out हो जाएगा तो 1 minus 1. तो टोटल line integral f bar dot dr bar is equal to along OAB f bar dot dr bar plus along BO f bar dot dr bar. तो along OAB क्या आ गया हमारा 19 by 20 minus 1. ये बन गया minus 1 by 20. ये हो गई हमारी LHS. f bar dot ये हो गया हमारा लाइन इंटीग्रल. तो बोलेंगे हम लोग इक्वेशन नंबर 1. तो हमें एग्जैक्टली सिमिलर वे डबल इंटीग्रल निकालना है ना. डबल हमारा स्टेटमेंट क्या है कि हमें दोनों प्रूव करना है कि डबा v बाय डबा x माइनस डबा u बाय डबा y dx dy ये सेम आ रहा है. तो पहले डबा v बाय डबा x सो m dx प्लस n dy u dx प्लस v dy. तो ये हमारा u है ये हमारा v है u dx प्लस v dy है ना. तो u इज इक्वल टू हमारा xy प्लस वाई स्क्वायर बन गया राइट. और v बन गया हमारा x स्क्वायर. तो यहाँ पे हम लोग लिखते हैं u dx प्लस v dy. तो ये हो जाएगा डबा v बाय डबा x डबा v इज इक्वल टू x स्क्वायर. here v is equal to हियर v इज इक्वल टू एक्स स्क्वायर, तो डबा v बाय डबा x बन गया 2x एंड u इज इक्वल टू है एक्स वाई प्लस वाई स्क्वायर, है ना। v इज इक्वल टू है हमारा यहाँ पे एक्स वाई प्लस वाई स्क्वायर, सो ये तो u है, तो डबा u बाय डबा y क्या बन गया, ये x, डबा u बाय डबा y x ओनली प्लस 2y. So integrating this with respect to y. So x plus 2y हो गया डबा u by डबा y. तो अभी x plus 2y बन गया डबा u by डबा y. So to consider now here the equation is y is equal to x square and y is equal to x. तो हम लोग को यहाँ पे देखना है कि y कहाँ से कहाँ वैरी होता है. तो ये चेक करने के लिए what we will do, इंटीग्रल चेक करने के लिए हम लोग क्या करेंगे, यहाँ पे एक स्ट्रिप निकालेंगे जो पैरेलल टू वाई एक्सिस. आप पैरेलल टू एक्स एक्सिस भी निकाल सकते हो, जो भी आपको ठीक लगे आप निकाल सकते हो, तो उसके अकॉर्डिंगली आपके लिमिट्स चेंज होंगे. अब यहाँ पे y का लोअर लिमिट हम लोग देखेंगे, तो y यहाँ पे टच हो रहा है, ये जो स्ट्रिप है वो ये कर्व को टच हो रही है, लोअर लिमिट लोअर एंड होगा आपका y इज इक्वल टू एक्स स्क्वायर को ये स्ट्रिप टच हो रही है. ओके, सो ये आपका लोअर लिमिट बन गया y इज इक्वल टू एक्स स्क्वायर, और ये अपर लिमिट अपर कर्व को टच करिए y इज इक्वल टू एक्स, तो हमारा y चेंज होगा फ्रॉम एक्स स्क्वायर टू एक्स. तो स्ट्रिप जो है हमारी वो लेफ्ट टू राइट वेरी होगी, तो हमारा x का लिमिट बन गया, मतलब x एक्सिस से वेरी होगी, तो x का लिमिट बन गया हमारा 0 टू 1 और y का लिमिट बन गया हमारा x स्क्वायर टू x. डबल इंटीग्रेशन है तो दोनों के लिमिट निकालने पड़ेंगे हमें. तो ये y का लिमिट निकालने के लिए मैं क्या करती हूँ, ड्रॉ अ स्ट्रिप पैरेलल टू y एक्सिस एंड सी वेयर द लोअर एंड टचेस टू द कर्व. तो लोअर एंड कहाँ पे टच हो रहा है, ये लाइन को, सो y इज इक्वल टू एक्स स्क्वायर को, तो y इज इक्वल टू एक्स स्क्वायर को टच हो रही है और अपर एंड टच हो रहा है y इज इक्वल टू एक्स को, राइट. तो आपका जो लिमिट है यहाँ पे, तो डबल इंटीग्रल ओवर r डबा v बाय डबा x माइनस डबा u बाय डबा y dx dy इज इक्वल टू बन गया हमारा, अभी y का लिमिट हो गया हमारा x स्क्वायर टू x और x का लिमिट हो गया हमारा 0 टू 1. Okay? So x is equal to 0 to 1 and y is equal to x square to x. ये समझ में आ गया. 0 to 1 क्यों है, बिकॉज हमारा पॉइंट ऑफ कॉन्टेक्ट 0 0 and 1 1 है, तो x वेरिंग फ्रॉम 0 to 1 है, y वेरिंग फ्रॉम आल्सो 0 to 1 है, बट यहाँ पे y की लिमिट्स है यहाँ पे x स्क्वायर टू x. अगर आपने स्ट्रिप पैरेलल टू x एक्सिस निकाल दी तो आपको उस हिसाब से निकालने पड़ेंगे, तो x के लिमिट बन जाएंगे, सी हियर अगर आप स्ट्रिप पैरेलल टू y एक्सिस निकालते हो तो x की लिमिट बन जाएंगे आपके x टू x इज इक्वल टू रूट वाई, तो यहाँ पे मिल जाएगा y टू रूट वाई मिल जाएंगे लिमिट्स, और x फिर से y वेरी होगा 0 टू 1. तो एग्जैक्टली सिमिलर वे हम लोग यहाँ पे करेंगे. मैंने यहाँ पे स्ट्रिप निकाली है पैरेलल टू y एक्सिस का, कैलकुलेशन मुझे इजी लगे. तो यहाँ पे हो गया y इज इक्वल टू एक्स स्क्वायर टू x, x बन गया हमारा 0 टू 1. जस्ट पुट हियर डबा v बाय डबा x क्या है हमारा, आ रहा है 2x माइनस यहाँ पे डबा u बाय डबा y आ रहा है x प्लस 2y इंटू डी एक्स डी वाई, राइट. तो ये बन गया इंटीग्रल 0 टू 1 y इज इक्वल, यहाँ पे x स्क्वायर टू x है. ओके, तो इंटीग्रेशन करेंगे हम लोग 2x, तो ये बन गया, सिंप्लीफाई करेंगे x स्क्वायर टू x, ये 2x माइनस एक्स प्लस 2y, ये बन गया x प्लस x माइनस 2y इंटू डी एक्स डी वाई. तो इंटीग्रेटिंग दिस फर्स्ट विथ रिस्पेक्ट टू y, तो पहले y से करेंगे इंटीग्रेट, तो क्या मिलेगा हमें, ये इंटीग्रल डबल इंटीग्रल ओवर द रीजन r डबा v बाय डबा x माइनस डबा u बाय डबा y इंटू डी एक्स डी वाई इज इक्वल टू, यहाँ पे होगा x इक्वल टू 0 टू 1 और इसका इंटीग्रेशन इंटीग्रल x स्क्वायर टू x इंटीग्रेशन है माइनस 2y का dx dy. So integral 0 to 1, इसका इंटीग्रेशन क्या होगा विथ रिस्पेक्ट टू y, xy माइनस into y square by 2 from x square to x dx 0 to 1 xy minus 2 to cancel out, okay, xy minus y square, okay, y minus y square from x square to x is equal to integral 0 to 1, यहाँ पे हो गया, ठीक, तो यहाँ पे हो गया x 0 to 1 इंटीग्रल फ्रॉम 0 to 1, तो ये हो गया x square, तो x square माइनस यहाँ पे x square है तो 0 बन गया, स्क्वायर माइनस एक्स स्क्वायर तो ये 0 बन गया, माइनस यहाँ पे है एक्स क्यूब माइनस x raised to 4. Okay. Now, integrating this with respect to x. So, you will get integral from 0 to 1 minus x raised to 4 by 4. ये minus minus plus बन गया. Okay. Plus x raised to 5 by 5. Okay. From 0 to 1. ये बन गया minus 1 by 4 plus 1 by 5 minus 0. Minus 1 by 4, so minus 5 plus 4 minus 1 by 20. तो आ गया LHS is equal to RHS. तो हमारा डबल इंटीग्रल ओवर द रीजन R भी आ गया minus 1 by 20 और फर्स्ट इंटीग्रल आ गया हमारा लाइन इंटीग्रल भी आ गया minus 1 by 20. So LHS is equal to RHS. Okay, so Green's theorem is verified. Hope you are clear here how to elaborate the Green's theorem. Now, verify Green's lemma here. Verify the Green's lemma in the plane for closed integral over C 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the boundary defined by x is equal to 0, y is equal to 0 and x plus y is equal to 1. So here your closed integral over C 3x square minus 8y square dx plus 4y minus 6xy 4y minus 6xy dy. Okay, here x is equal to 0, y is equal to 0 and x plus y is equal to 1. X is equal to 0, y is equal to 0 and x plus y is equal to 1. So I2 is varying from 1 to 0, 3x square. So you will get here x square I2 is equal to here 3x square plus, and right here I2 3x square minus 8 into 1 minus x bracket square dx plus 4 into bracket 1 minus x minus 6x into bracket 1 minus x minus dx. Okay. So after calculating this, you will get I2 is equal to here integral from 1 to 0. Here you will get integral from 1 to 0. Okay. Ultimately you will get here x cube by 3 minus 15 into 1 minus x into minus 1. Yeah, plus 16 into 1 plus x. So ultimately you will get the total calculation of doing this plus 4 minus 1. Here is minus minus plus minus 4 plus 4. Yeah. Minus minus plus बन गया 6x plus 6 square by 2 plus and minus 2 by from 1 to 0. we'll get I2 is equal to, after doing all this calculation, we will get I2 is equal to 8 by 3 and I3 will be along BO. Okay. So along BO, we will get along BO here y is equal to x is, along BO x is equal to 0, so dx 0 and y is varying from x is varying from here y varies from 1 to 0. We will get ultimately here 1 to 0 along 0 plus 4y dy plus 4 into y square by 2 from 1 to 0. We will get here minus 2. So minus 2. So total line integral f bar dot dr bar you will get here is u dx close integral over is close integral u dx plus v dy is equal to, you will get along OA plus along AB plus Q. So ultimately you will get 1 plus 8 by 3 minus 2 equal to by 3. Your final answer is I1 plus I2 plus I3 is equal to 5 by 3. You can verify the second one, that is u is equal to here 3x square minus 8y square. U is equal to 3x square minus 8y square and v is equal to 4y minus 6x. Okay, so you can calculate dabba u by dabba y. So minus 16y and dabba v by dabba x is equal to, dabba v by dabba x is equal to minus 6y. Okay, get minus 6y. Now here we will draw a strip parallel to y-axis. Here we will draw the strip is parallel to y-axis. Then we will draw a strip which is parallel to y-axis where y varying from 0 to y is equal to 1 minus x. Y is varying from 0 to 1 minus x. So you will get here double integral over the region R, dabba v by dabba y, v by dabba x minus dabba u by dabba y, dx dy is equal to double integral y is varying from 0 to 1 minus x and x is varying from 0 to 1. So here we'll get dabba v by dabba x minus 6y minus of minus 16y into dx dy. So integral from 0 to 1, integral y is varying from 0 to 1 minus x. यह हमारा plus 10y. Integrating first with respect to y. First with respect to y, so you will get 10y square. Integral from 0 to 1, 10y square by 2, so you will get from 0 to 1 minus x dx. Integral 0 to 1, 5 y square 0 to 1 minus x. So 5 into square म्हणजे काय y cube by 3 from 0 to 1 minus x dx. Integral from 0 to 1 into integral from 0 to 1 1 minus x 8 cube by 3 minus 0 dx. So it is integral from 5 into by 3 from ये हो गया फिर से 1 minus x square का again you will get so 5y square या 5 into 1 minus x bracket square. into 1 pi square by 2. 1 minus x cube from 0 to 1 of this 1 minus x cube to 1. So that's equal to 1, it is 0 and 1. So if you observe the LHS and RHS of both the integral are same, so which implies the line integral Green's theorem is here verified. So in some example only evaluate the line integral is given. We can evaluate the line integral by Green's theorem only. So either we can use the line integral or we can use the double integral over the region bounded by that given closed curve. के दोनों रीजन से बाउंड किया हुआ जो भी कर्व है वो वहां पे रीजन का इवेल्युएट करेंगे इंटीग्रेशन अदरवाइज ये करेंगे सो दोनों भी सेम है okay so I hope you are clear here how to find out the line integral by using uh, Green's theorem and by the region bounded by the two closed curve by using Green's theorem also here we can evaluate the line see तो क्विक रिव्यू लेते हैं क्या क्या किया हमने इस लेक्चर में Here vector identities, very important vector identities here. Properties of del, we have seen how to elaborate these properties that already elaborated. This main properties that is del of f of r is given, then how to evaluate the del of f of, with the help of del of f of r, how to evaluate the other identities. Okay, now this is also the main del square of f of r, how to evaluate this. These two formulas are very important to use and to solve any identity depending upon del of f of r, we can use that two identities. Okay. Now this is also, now this will also very important and the line integral, how to find out the line integral is nothing but the work done, how to calculate the work done when the path of integration is given and second one when the path of integration is not given, here path of integration is given, we are taking two different curves. In the first example we are taking only the straight line and in this example we have taken the two curves that is uh, the curve y square is equal to x and next, when the path of integration is not given, first of all, we will find out the path of integration and then evaluate it. And the last one that is very important, Green's theorem. What do you mean by Green's theorem? The line integral is same as the region bounded by that closed curve C. Okay, so we evaluated as it is here the line integral with the region when the curve C is transferred in anti-clockwise direction or everything that we will see here. Verify the Green's lemma in the plane surface. The plane for this. The two different curves are given. In the first curve it is a combination of or the closed region bounded by the parabola and the line. The second example we have seen and how to find out the integral limits. That is very important part here we have how to find out the line integral. See, we will see in the next lecture that is surface integral Gauss divergence theorem. In that also we will evaluate the line surface integral. It means double integral and double integral over the region bounded by the curve and the triple integral volume integral also we will evaluate in that and how to find out the surface integral that we will see in the next lecture. I hope you are clear here how to find out the line integral. Okay, so much. If you are liking my videos, please do like, share and subscribe. Bye. We will meet in the next lecture.